So we have a very special guest coming on the show this afternoon, and he is the developer behind mergerfs. But joining me in studio today is the host of ChooseLinux, Drew.
Hello, hello.
And I also have the one and the only Brent.
Well, hello.
And the reason we have these two folks is Brent has never used mergerfs before. He is a curious mind. He is looking to build the ultimate photo backup storage solution. Is that right?
I don't know about ultimate, but I need something that really works for me. So.
Yeah, that pile of external hard drives.
Don't tell them too much about that.
Oh my goodness. I was watching a video with Linus Tech Tips and the guy behind, what was it? Smarter Every Day. And Linus went to this guy's house, and he lives in Alabama near the like Rocket City, what's it called? Just outside Atlanta. Anyway. And this guy had huge plastic totes. I'm talking, he had over 100 terabytes worth of external hard drives, all neatly labeled. And this guy went to a spreadsheet and looked at, right, I want to reference this project. I want to look for Apollo landings. I need to go to hard drive Q37. So you go to box Q, get out hard drive 37 and copy that folder to his...
Was he a librarian before he started doing this?
I have no idea. But
Did he use the Dewey Decimal System?
It's a heck of a system when we have projects like mergerfs in the world. So,
yeah.
Drew, what's your background with mergerfs?
I've been using it since I found your blog post talking about mergerfs and its joys, and I've been loving it. I run it on Ubuntu 18.04 server with a bunch of Docker containers and...
Linux containers, you mean?
Well, yeah. I mean, okay, so yes, they are containers running under Docker.
I call them Docker containers all the time as well. I'm just as guilty.
Well, I'm using it with Docker. If it were Podman, then they'd be OCI containers.
Correct. So the funny thing is, before the show, actually, we were just talking, and I showed Drew my blog post from 2016, and he went, I've read this before.
Yes.
Long before we met, because we first met at Linux Fest Northwest this year in April.
That's right.
And it's just funny how the internet is it's such a small community that you never know who you're going to run into.
Yeah, it's a little world. But yeah, it's that got me up and running with mergerfs and snap rate on top for parity. And I am a big, big fan. So I'm really excited to talk to Antonio here.
And what do you do with it? Is it mainly media files?
It's media, Nextcloud, mail. I got a little bit of everything going on. It's a big, big server with lots of RAM and lots of storage. And
so you're not running databases off this thing then?
Well, there's a Nextcloud database. Does that count?
Maybe not.
Yeah, maybe not. I mean, nothing high power.
For your container app data, how do you handle that? Do you have a separate mount point?
Yeah, so I found that mergerfs wasn't very good with databases, so I ended up moving all of my databases and what I call control for my containers over to an SSD, and then it's just data, just dumb data living on the mergerfs pool, and it does a great job.
Write once, read many, that's where it excels.
Exactly right.
Large, static, often unchanging data sets. And so we've heard from Drew and Brent. I'd like to pull in Antonio at this point, who is the main developer, I think the only developer of mergerfs, actually. Looking through the GitHub, he has 69,000 lines of code to his name, and the rest of the world has about 70. So, Antonio, it's great to hear from you.
Thank you for having me.
Well, thanks for being on the show. So, first of all, I wanted to ask you, what is mergerfs, in your own words?
It's a... union file system. I don't know. I think my tagline on GitHub right now is a featureful union file system. It's just a simple way of taking a union of all the directories and files that you may have on across a number of file systems, or even the same file system but from different paths. So it's more or less just a proxy with some smarts for routing where the specific functions of a file system get dispatched to. So it's really just like any other proxy, mostly. I mean, there's some additional features that are relevant for the file system space, but if you think of a web proxy or anything else, it's largely doing the same thing. And the purpose is just to simplify that workflow, that behavior. There's many use cases for unionizing existing file systems, and there are many different implementations. And I created mergerfs due to a technical limitation that existed in the different popular implementations that were out there at the time.
Yeah, I use it a lot. And the way I would explain it is it allows you to take just a bunch of drives and make them appear as if they're an array of devices, if you like. So you could have 5, 10, 20 different hard drives, each with an individually readable file system on it, and present that under a single mount point for your applications to use. Is there a limitation out of interest on the number of devices that we can put together under Merger?
Not a specific one.
65,536, I guess, right?
Not even that. It'd be the amount of RAM that you probably have. I think you're going to run out of connections before you run out of like physical connections to mount drives before you run out of the ability to merge them together.
I had a question about, you mentioned there was a feature that was missing in most of the popular system alternatives that you were looking at previously. Can you mention that specific feature that kind of made you dive in?
Well, I think the biggest, this might not be a feature per se, but support was a big one. mhddfs, which I think a lot of people used to use, and I find a number of people still use. The author had abandoned it quite some time ago. That was one of the primary reasons I started looking into this space. And when I did, I recognized quickly that there was a lot of security issues with the software and a lack of configurability. So I think one of the biggest features for mergerfs versus mhddfs is the ability to choose what I call a policy in the way in which it figures out which drive or which branch to work on within the union.
So this is a really interesting feature of mergerfs that I absolutely love. And this is the create policies. So how would you explain it to the layman, right? Because the first and the default setting is existing path, most free space. So, I mean, how would you explain that to the layman?
So most free space should be somewhat obvious. You know, each drive has X number of bytes, and if we look at the more simple version of that policy is just most free space. At the time a create request comes in, it simply looks at all the drives at that time, takes a snapshot of those values of how many bytes are free, and just picks the one with the most. It's a very simple algorithm. Most of the algorithms are quite simple, and it's a snapshot in time, unless it's being cached. There's some caveats there, but the existing path part, in retrospect, I actually regret making that the default because it leads to a lot of confusion. But the intent was, so existing path, there's a behavior in mergerfs called path preservation. So imagine you have 4 drives and you want media of some sort on one, say movies, TV shows on the second drive, and you have a lot of ebooks and you want them on the other 2 drives. And the path preservation would allow you to sort of manually go in, create the paths in each of those drives that you wish to have that particular data on. So you might make a movies directory on the first one and a TV directory on the second one and books on the third and fourth. And so the path preservation will filter out, in effect, the drives when it's making a decision based on the path, the relative path of that file. So it's kind of basically, it does a dir name, if you were thinking of it from like a command shell perspective, and looks for that path across all the devices. And if it finds it is included in the kind of secondary filter, which is most free space. And there's other filters too that happen at that time. But so it's kind of creating subpools based on the directory hierarchy.
Could you see this as almost like a hybrid approach in which, you know, the defined folders that you've preset on those specific drives are sort of chosen ahead of time, are sort of the legacy way of storing data as we typically see it. And then everything else that you pool on those drives is just sort of dealt with through the algorithms? Would that be a way of seeing it?
Yeah. I mean, most people, grow out their collection of devices, their storage devices, pretty organically, unless you're a business or whatever. And you tend to kind of just put this drive's going to have X, and this drive's going to have Y, and that drive's going to have Z. And then you have to remember which drive is where, which one contains which data.
Sounds familiar.
Right. This data manages that, or this behavior, I should say, manages that for you. It does require a little overhead. It does require you to either seed those paths or to, at some point, in the future, to manage them if a drive becomes more full or not. And that's why I was saying that there tends to be a confusion, because as default, if you follow through step by step of, if you have a pool of a number of drives and they're all empty, then the first time you create a directory, it's going to end up on one of those drives with the defaults. And so a lot of people get caught up and they're like, oh, I just copied over a huge amount of data to my pool and it's all going to one drive. And that's because the very first makedir happens on one drive and they all had the same amount of space free effectively. And then that one path is then used for, all the subdirectories are associated with that path. So it's something I can't really change now because it's the default. But if there's a mergerfs 3, I might change that.
If you were to change it, what would be your preferred default now?
Just most free space. I think the average person using mergerfs that's what they're expecting. Some people would prefer percentage-wise or least free space or whatnot, but I think most free space is kind of the common expectation.
I think that's wise. I'm a mergerfs user myself, and I was a little taken aback when I first discovered that it was not using least free space or most free space, excuse me, and ended up switching to that and then balancing the drives, which leads me to another question. Is there a particular reason that you decided to keep the mergerfs tools separate instead of including them in the base package?
Mostly the release cadence and the language. So mergerfs is C++, and the tools, they're written in Python 3, and the reason there is just they're doing very simple things. It's kind of easier to get off the ground, and I wanted the tools to be more easily manipulated by third parties, because it really started as examples of how to accomplish certain things out of band so that they didn't have to be in mergerfs. The concern I have is that, I'm the file system, or mergerfs is your file system, or at least a proxy for your data. And if I ever screw something up in mergerfs, I can screw up your data. Worst case, I could corrupt it silently. Best case, maybe it crashes or it, deletes a file, hopefully that's, in an obvious way or whatever. But there's a lot of subtlety there. And granted, mergerfs is way, way, way more simplistic than most file systems. But Fuse, historically, has not always been the most stable. So I was kind of bounded by the stability of libfuse and the kernel. And for any of those who have followed Fuse or mergerfs over the years, they've seen that there's a number of issues that are outside of my control. And so with that in mind, I've tried very hard to limit what I put into the main product so that if there are any issues, these things can be managed out of band, or at least, like, even if mergerfs isn't there. Because one of the nice things, one of the appealing aspects of mergerfs that a lot of users say is why they like it is that you can always take it out. You can always remove it, and there's no... mergerfs isn't really a file system. I mean, technically it is, but in terms of the traditional sense where it's controlling the blocks on the device, it's not doing that. It's just a proxy. And as a result, you can always remove it, and all your data is going to be totally accessible. And that has other side effects, meaning if you have a drive that dies, you only lose that one drive. You still have full access in real time to all your other data. But making everything this separate repo, separate apps, it's in that vein. so that if you want a balance tool and I didn't write the balance tool the way you want, it's Python. There's a lot of people that know Python. Go at it.
So you touched on the balance tool just then. Which of the other tools do you think that people need to know about that they perhaps don't?
The dupe tool can be useful. So it allows you to point at a directory or a file and give like a number of copies that you want, and it will find the drives with the most free space and uses rsync under the covers, because I'd rather than trying to create all that very solid logic of copying files safely, I just leverage rsync. But Python is orchestrating that, and it will go and find a drive, make n copies, and it'll just kind of recursively go through the path that you have instructed it to. That's quite useful if I know a drive pool has the ability to replicate across a number of drives. mergerfs doesn't, and in some ways that's purposeful, but this kind of allows you on a schedule to do something similar. There's the fsck tool, which I don't think I've updated in quite some time, but a lot of issues with mergerfs come down to permissions, and that tool can help suss out some of those permission issues. For instance, if you have two relative paths on two different drives that have different permissions or owners, then it can help you find that.
I ran into that issue the other day, actually. So I now know how to fix it. Thank you.
Yeah. One of my coworkers has for a long time complained that I allow there to be inconsistencies on the underlying drives. But the problem is, with it being a file system, you really don't have a good API or mechanism for reporting that you found these inconsistencies. And while I could, in effect, just when I notice it, report it in some log somewhere, why add that to the main product and complicate the code when it's just as simple as to write something in Python that just does an audit once in a while? Usually the only time you need that is when you're mucking around underneath mergerfs or you're adding in pre-existing drives. So it tends not to be something you need that often, but I think it was the first tool I wrote.
I guess the other question there is, could the file system just be doing that, since it has, maybe that's a job it should be doing as well?
So mergerfs really needs to be running as root, and certainly I could go and change permissions or change owners or whatnot and try to make them consistent. But what's the heuristic, right? So if you have 4 drives and 3 of them say it's owned by nobody and the fourth one says it's owned by root, what do you choose? Do you choose the one based on the policy for stat? Do you do it based on a different policy for a different function? It's not really clear. And to try to make it configurable adds like a whole nother level of configuration to the product that would almost never be used by most people.
I wanted to touch on the fact that you say that it's safe to run as root, and I was just wondering if we could talk about the security of it a little bit. I'd like to know a little bit more about what safeguards you have in place for that.
Sure. I mean, there's a section in the docs which I try to recommend everyone look at the mergerfs docs. I have a long career in software development, and documentation tends to be very crappy for most products, and I spend a lot of time working on docs. So when in doubt, first check the documents.
From a user to the developer, I'd just like to say a huge thank you. It makes such a difference when someone puts this much effort into the docs. So yes, please, if you're listening and haven't read them and are interested, go take a look.
And these are some of the best written docs I've seen in any project in a long, long time. They are really fantastic and robust. So yes, thank you.
Thank you. That said, I am biased. It is my software, and I've been using it for a long time, and I'm very intimate with systems level development. So if there's anything that is unclear for some Linux newbie, which that tends to be the issue, feel free to contact me. There's all my contacts are also in the documents, so I'm happy to try to reword anything to make it more clear. But back to the original question. So there is a section in there where I go over this relative to mhddfs. So mhddfs could be run as root, and in fact generally expected you to run it as root if you were only ever running stuff as one user ID, then you probably wouldn't ever notice if you didn't run it as root. But in the code, there are very explicitly assumptions that it has the ability to chown or chmod any random file. And the way it worked was, let's say it creates a file, it would create the file as root and then change the owner to whatever it was supposed to be, based, because the way Fuse works, you get an instruction or a command from the kernel, and part of the payload is to say, this is the PID it came from, and this is the user ID and the group ID and some other metadata. And so you know who has made this request on the other side from the client app. And mhddfs would simply chown or chmod the file after creating it as root. Now, from a security perspective, that's not actually a bad idea. However, that leads to non-POSIX standard behavior, because if you're root, you cannot, in traditional file system APIs, you couldn't really replicate the permission checking that would happen in the same way that would happen via the kernel. So your root, you can, ignoring capabilities and such, you can basically open any file, and in certain circumstances, it would allow you to. So you would be able to do things through mhddfs running as root that you shouldn't be able to do. The proper behavior is to change, before you do any of these commands, to change to that user, to that effective user, or effectively change to that user, I should say. And that's what mergerfs does. So anytime a request comes in where the user ID is relevant, because not all, there's a overhead to changing user IDs, and so I don't do it if it's unnecessary. For like a read and a write, the kernel doesn't actually check the permissions. So if you chmod or chown a file while you're reading and writing it, that's irrelevant to the situation, and so I don't actually change for those commands. But anything else like stat or create, make dir, etc., the only secure way to do that is to become that user and then to take that action just like you would normally. And so that's the biggest security change relative to the mhddfs and some other similar file systems out there. It's in effect the same thing that Samba does, and I use the same tricks that they do. So in Linux, or I should say POSIX in general, says that every thread within a process needs to be the same user ID. But Linux doesn't work the same way as traditional Unix, and it uses, for those who are familiar, the clone system call, which is a much more flexible version of fork, basically. And every thread can have its own user ID and its own credentials. And so I abuse that by calling directly into the kernel so that as a multi-threaded application, mergerfs can simulate being multiple users at once. And this is a behavior that Samba also uses.
That's super interesting. I always wondered why there were so many processes showing up in top or something, and now I know why.
The number of threads are configurable now. That was something that when I vendored the libfuse library, I made that more configurable, because you do lose some throughput when you increase the number of threads, because there's more contention on the pipe going into the kernel. But generally, yeah, that's why you by default will get one thread per core, and then there's a primary thread.
Let's shift gears a little bit. What considerations do people need to make in terms of CPU? Because traditionally, one of the limitations in Fuse has been its high, quote unquote, high CPU usage. What sort of CPUs are people going to need to sustain a gigabit transfer, for example?
That's hard to say. For those who don't know, Fuse is a serial protocol that that the kernel exposes to user space, and it allows a user-land application to serially communicate over a device, DevFuse, and every time, say your client app is LS, every time it's making some system call that's a file system API, it's got to go into the kernel when the syscall, say an open is called. There's the open from the app gets translated. There's a wrapper for the C library. Then that calls a system call into the kernel. And with Fuse, it's got to see, oh, okay, you're talking to a Fuse file system. So I have to look up who's on the other end of this file system, transfer that through this character device. And that's kind of where this overhead comes from. So you have to go into kernel space, into user space, from user space, back at, well, as a proxy, I'm going back into kernel. Like, so mergerfs is going back into the kernel to ask the question like, okay, I need to stat this file, whatever the original app was asking. So that's another round back into the kernel, then back into user space, and then back into the kernel, and then back to the original app. So there's a lot of latency there because it's copying this data back and forth into the kernel, and that there's a lot of overhead to that. And it's CPU intensive, not in the traditional way. So it's more IO intensive. And because it's a user land app, you're seeing the CPU utilization. So if you're using ZFS or Btrfs or similar, those can take a lot of compute as well. But because they don't represent themselves in user space in quite the same way, you don't see the CPU grinding away doing block deduplication or in ZFS or the RAID behavior or whatnot. And so in some ways, I think Fuse gets a bad rap because of that, because you're seeing the actual compute that it needs. That said, there is this extra latency introduced because there's these extra hops going in and out of the kernel. And the speed at which it can do that it doesn't seem dependent entirely on the CPU. So I have had people use Raspberry Pi 2s and no problem whatsoever, fully, getting full throughput as they would expect, either from the NIC or the drives they have connected, and minimal CPU utilization. And I've had people on Xeons say that their CPU utilization is through the roof. And I haven't been able to figure out why that is. I've had similar systems, same kernel, same OS, different drives and HBAs or controllers for the drives, and had different behavior between the two. And I'm still trying to figure out why that is. I don't know if it's a driver issue. I don't know if it's a drive issue. If there's a bunch of other crap going on the machine that's not being accounted for issue. It's hard to say. And what I really need to do is there's all these variables and arguments that I allow to be modified in mergerfs that I would like to hide from the user. But the reason that they're there is because I found that different people get different performance based on those different options. And what I really need to do is stop being lazy and build a benchmarking tool that just kind of goes through all the different permutations of those arguments and then runs, a very simple DD kind of benchmark and tries to find the best permutation of values.
You heard it here first, folks. mergerfs 3 is going to have a built-in tool for testing performance.
Nice.
So I had another question for you. How long has mergerfs been around, and what was your motivation really to create it? I know you touched on that at the beginning with the lacking features in other products, but just curious, really.
Sure. How long it's been around? We'd have to check GitHub. It's been longer than I'd probably say. Because, for instance, this other tool I have, BBF, that I've been working on recently, which is a tool that is kind of bad blocks plus HD parm plus some extra features. That tool I thought I wrote like a year ago, and it turned out I wrote it 3 years ago. So my memory's not so good.
Yeah, time flies. It really does.
But I guess a little backstory is that I've always been a media collector. So in the 80s and 90s, I had all the CDs and all the movies. And once it became financially viable to store digital media in bulk, I started doing so. And I had a iRiver H340 with all my OGG level 6 encoded, or OGG Vorbis level 6 encoded music. And I had to immediately, when I bought it, I bought an upgraded hard drive on the third party and took it apart and upgraded the hard drive to like 60 gigs, I think it was, just because I had a bunch of music and I wanted all my music in one spot. And as my music collection grew and hard drive prices declined, I started ripping my DVDs. And I never liked the idea of transcoding it to some other format, especially because even if you're not someone who's ripping and then selling, which I don't, I just have tons and tons of CD holders, DVD holders up in the closet, but just re-ripping stuff is a pain. And so I ended up slowly building this hard drive collection. And it became, as soon as I got to a point where one hard drive couldn't hold the full collection of certain type of media, it got really annoying. And that's when I started looking for a solution, which led me to mhddfs. And because that was so simple to do, and I wasn't going to spend the money for a RAID setup or whatever.
I think we both used mhddfs for a while, because before I used mergerfs, I used mhddfs and aufs and unraid for a bit too, and I even tried FreeNAS. And then your tool literally came out of nowhere. I've just found the first commit. It was March 2014.
Yeah, and I had a coworker who was also using mhddfs, and I was a data hoarder. And
oh yeah, I love that subreddit. Do you?
Oh, I'm on there, and you'll find me anytime there's I have a if then that search for mergerfs. So people apparently know that anytime something comes up, I come in and snipe a response.
You do. I've noticed that. Every time I post something, there you are, like a bad smell.
Yep.
So what does your home server look like? How many terabytes are we talking?
I have... I do have a wiki page on the mergerfs GitHub account or whatever repo. And I invite people to go there and add their own home setup. Mine's on there. So I have currently... So I just redid my system. So I actually don't have that fancy of a setup, though I do have a lot of storage. So I used to just have a 4-port eSATA AS Media based eSATA controller card. And then I had 4 IC dock port multiplier 4-port enclosures. They fit well in my entertainment center. I don't need a lot of throughput. It worked. But when it doesn't work, it really doesn't work, because unfortunately port multipliers don't handle failing drives particularly well. And so just about a month ago, I decided I was fed up, and I bought a old LSI 9201 4-port 16-port HBA, and I bought 2 generic 8-bay 3.5-inch drive enclosures.
I assume you flashed that LSI thing to IT mode.
Yes. And these enclosures, I linked to them on the wiki page. I'd never come across them before. They're basically if you've ever seen an 8-port SANS digital, it's that enclosure, but without a backplane or anything. And so it's pretty bare bones, but at $70 shipped, it's pretty nice if you're just kind of putting your own thing together and you don't have rack space, which I don't. I'm in a Manhattan apartment downtown. So I bought 2 of those, and I bought 4 mini SAS to 4-port SATA connector cables, and just fished the wires through and hooked it all up. And that's what I'm on now. It works. It's way more stable. So I have, I have 12 8-terabyte drives. I have a few thrown in there that were like dying drives, like a 1, a 2, 1.5, something like that I'm using as guinea pigs for my hard drive tool. And then I have the audio isn't bad, or how loud the drives aren't that bad. They're all sitting in my living room. And I'm in Manhattan. There's a lot of outside noise, so it kind of all drones together. It's not the biggest of deals. But in terms of heat and the noise, especially from the fans, gets annoying at times. I have updated the fans, so they're less awful. But in any case, I've kind of started moving to 2.5-inch 5 terabyte drives. The Seagate, I forget what the serial numbers are, but in any case, they're the only 5 terabyte 2.5 drives out there. They're reasonably priced per terabyte, and I've started using those. So I have 3 of those now, and so my total capacity is around 100 terabytes, and unfortunately, it's almost full.
So that's really impressive. Do you have any kind of parity on there?
I don't. So I used to use SnapRaid, but I was using CrashPlan. So if you look in the trap exit GitHub account, you'll find a repo that's just examples on how to set up different environments, different storage environments, and how to use different tools for maintenance and formatting and et cetera. And you'll notice that there's numerous mentions to CrashPlan, which I still technically have a CrashPlan plan, but I haven't been using it much lately. And for those who don't know, they were kind of the last, maybe kind of still are, besides, I guess the only cross-platform, fully unlimited backup service, like true backup service, not a cloud kind of data source like G Drive or Dropbox. And so I know a lot of data hoarders, including myself, use that for years. But the company I don't think is doing that great or whatever. So that was kind of my backup plan, because it once I successfully backed up all my data, that was fine, right? Because I also have another tool called Scorch, which is used to find bit rot. So if I ever lost a file or a drive, if I ever found bit rot, I could just restore it from CrashPlan. And because it was true backup in the same way that maybe Time Machine or snapshots in ZFS or ButterFS are, then it really wasn't a big deal. I really didn't need parity or any sort of backup like SnapRaid. When that started giving me a problem, mostly because they store all their data when they're scanning your drive in memory, and so you need a ton of RAM to scan, and the more data you have, the more RAM you need, and it just doesn't scale well. I did move to SnapRaid for a while, but I realized that if I had a different backup service, then I could get rid of that again and get that storage back, which at the time I really needed, similar to now, I guess. And so I kind of got off of SnapRaid at that point when I found a better backup service, which is I use G Suite now and rclone, and that works quite well for me.
Very well. Yes, I use that myself as well. So you mentioned snapshots just then. Is there any technical reason why snapshots couldn't ever make it into mergerfs one day? Is that something you might consider adding at some point?
It would have to be based on top of existing technologies. Like the underlying file system would have to support it in some way, because there's just too much going on there for me to replicate. I do have a number of optimizations that I really don't talk about because you wouldn't notice, but if you've ever used the GNU CP tool, right? Like CP, you're copying a file around. If you look in the man page, there's the reflink argument. And so certain file systems like ZFS, ButterFS, and new versions of XFS have this reflink thing. So this copy on write, the ability to say that this file and this file use the same blocks. And so if you're going to copy a 10 terabyte file, it can happen in a second, because it's really just making references to pre-existing data, which is how snapshots work. And so in mergerfs, when it is needing to copy a file from one location to another, and there's a few situations where that may occur, it'll try to use those optimized behaviors, and if they fail, it falls back to just traditional, read from one file, copy, and write to the other file. And so I could, in effect, extend on that, and if certain commands were made to mergerfs, I could forward them appropriately to the underlying file system. But because mergerfs is really just a proxy and I'm not messing with the data itself, there isn't a real way for me without, in effect, rewriting the whole product to offer snapshots.
Yeah, that makes a lot of sense.
You mentioned very briefly earlier how if mergerfs is removed from the system, then the data is still available on the drives. That is one thing that has kept me from exploring various options. I'm looking to build my own sort of storage system at my place, and I've been sort of looking at a bunch of tools, but haven't jumped in, although Alex has convinced me that mergerfs is probably the way to go.
It is. You can stop looking.
One big
now.
question that I have is, and which I have applied to all of my systems in various ways, is that I want to be able to understand the data if something goes wrong. So can you give me sort of a run through of what the data might look like if something goes wrong?
Exactly as you would expect if it was a single drive.
Well, I guess to dive into that a little bit, like I know let's say I write a file, it gets sent to the freemost drive. And so if I'm looking at several drives that have a similar folder, for instance.
Right. So, in that case, what you're going to have is a federation of that data across those drives, but at a file level, right? So you're not going to be, let's say you've got an album and you've got most free space enabled. That album, say you have 3 drives and there's 10 songs, and they all happen to be around the same size, you might end up with 3 files, and 4 files across those 3 drives. That's really not predictable at any one time. Obviously, at the specific time of creation, it's predictable. That's how mergerfs is working, though there is a random option policy. But you're not going to know ahead of time, obviously, where that data exists. However, it will be in the same relative path. You'll be able to very easily see that this specific data, you'll know that data is missing, but you're not going to be missing like half a file. You'll be missing maybe half an album, but you'll know every drive will have largely the same layout. They'll all have the same directories, or at least the directories that matter to be on multiple drives. You'll see the same relative layout.
But so to find like a specific file, we would then use find or locate or whatever search tool against the drive mount paths rather than the mergerfs pool, correct?
Right. And my tool Scorch, to plug that a little bit, I actually use that for this kind of use case. I need to enhance the tool to make it so right now it hashes everything. I want to make the hashing algorithm configurable, and that includes no hash. So that would make the tool more of an indexing tool. But when you're merging together all these different drives and you lose a random drive, it's incredibly frustrating to not know what data you're missing. Like, it's convenient that I still have my other drives live, and I'm missing only this one drive, but then you have to go through the process of fixing that situation. And I started writing Scorch in part because of that, where I wanted to know very simply, I wanted to have a database in effect that I can say, okay, show me every file in this system that I'm missing since my last update of the database. And if you pointed that to the mounts rather than, say, the union, then you could find exactly what files you are missing. Now, I'm going to probably release these random scripts that I have where it kind of creates an audit of every drive that's in my pool every day, and then creates a diff. And so, I use like log rotate to keep those for 90 days or something. So if I miss a drive or I accidentally delete something or whatever, I can just kind of unzip the file, do a quick grep, and find where the file was at any particular time in the past 90 days. And then that combined with Scorch, which I use to index all the data in my main union mount point, I can very easily find the data that I need to help me reconstruct the situation.
I need to start using this Scorch tool. It sounds wonderful. But just to expand a little bit on what's just been said, the key thing that mergerfs lets you do, and to be honest, it's the same with Unraid and many of these other kind of union file systems, is you still have an individually readable file system on each disk. And how that differs from traditional RAID or ZFS or something, is that rather than the data being striped across multiple drives, so if you lose disk 5, you better hope that the stuff that was on disk 5 is striped somewhere on disk 1 through 4. Whereas with mergerfs, like Antonio said, it writes entire files to a disk rather than partial files or anything like that. And so if you pull any of these drives from underneath mergerfs and stick it in another Linux system, you'll be able to read that ext4 or that xfs or that zfs drive. But, that for me is the real win of these kind of systems. Rather than striping data, it's individually readable on each drive. So
yeah, and there's certainly, and I try to make this very clear in the FAQ section for mergerfs, that this is not a substitute for certain workflows and workloads. RAID has its place. Granted, with very large hard drives, RAID is becoming precarious, but that aside, mergerfs is really meant for the casual user who has numerous random drives and they just want to have some kind of single view into their data, or prosumer who knows the risk or is using some other tool like SnapRAID or has full backups or whatever, and is willing to take these trade-offs between, okay, I can lose one drive and the rest of my system will continue to work just fine, and I don't have to worry about, okay, if 2 drives go, well, that sucks, I'm going to have to restore a bunch of data, or maybe I've used a path preservation policy, so I put all the data that I really don't care about on these 2 drives, so if they die, so what, and I back up the other number of 5 drives. Whereas on RAID, you may, if you lose 2 drives, all your data is gone. So it's really just about offering another tool, and I try to be very clear about where mergerfs falls flat and where it is more beneficial than some of these other technologies. And because it's so much more simplistic to use, certain people try to make RAID systems like, FreeNAS and Unraid, they try to make things extremely simple. I don't think it's safe for Unraid. I don't think it's the cost that is a barrier to people. I think it's, it's closed source, or it's just scarier. There's just a lot more knobs to tweak. I mean, granted, there's a lot of knobs to tweak in mergerfs, but out of the box, it just kind of works. And so most people, I think, understand that trade-off. And for a lot of us, it's worth it.
Yeah, but Unraid has a GUI and mergerfs doesn't, so it must be better.
I'm trying to fix that. The problem is I'm very much a low-level developer, and web development makes me want to rip my eyes out. And no offense to the web people, but
the web people, I love it.
The web people. Anyway, so I've looked into doing it myself, and that's probably just not going to happen. Ideally, in the same way that I try to make mergerfs as simple as possible, I know the guys over at Open Media Vault, they have their front end, and they have mergerfs exclusively as their union file system option, which thank you for them. But their UI is very simplistic, and obviously you have to have the whole package, and not everyone wants to use Open Media Vault. What I would like to be able to do is have a simple binary or script that someone can download, that it's its own web server that you run as root, or give proper permissions to access the mergerfs control runtime API. That would allow you to kind of just start up a web browser, go to whatever machine's IP address that you've launched it on, and just kind of drag and drop drives that you have. It'll query, the way I imagine is query all your drives, look at the ones that are probably your boot drive, separate them out from your data drives, and then give you click boxes or drop downs for all the different options for mergerfs. And then maybe, I think it would be nice after, if I could get that done, to add maybe some SnapRAID stuff, since that's a very common tool to use with mergerfs and anything else in that space. But I do have a number of web developer friends, but none of who are in this space. So I've been meaning to go on like Data Hoarder and Home Lab or any of those subreddits and just throw out a request to see if anyone's interested.
I wanted to say thank you very much for joining us. It's been a pleasure speaking with you. And from the community as well, I know that many people are very grateful for all the work you've done on this amazing tool. Do you have any way you'd like to send people to follow you, like Twitter maybe, or plug your GitHub?
Yeah, just you can find me. I mean, Trap Exit is so that username comes from Erlang. I was a big Erlang, or am a big Erlang fan, and kind of use that as my handle. You'll almost always find any service. If you look up Trap Exit, it's probably me. There's a few that aren't, but that's pretty rare. If you just go to github.com/trapexit, you'll find all my stuff. And I work on all these tools regularly. You can find me on Reddit or email, whatever. Like, contact me any way you wish. I have a Discord as well for those who want to chat about stuff. Yeah, I'm very open. Feel free to contact me any which way.
Well, thank you very much.
Thank you for having me.